Hi learners, and welcome to your lesson for Analytical Geometry. In this lesson we're going to be looking at angles of inclination, right? So I have 3 examples on the board, and for these examples we need our calculator. So one of the things that we have to understand when it comes to angle of inclination is an important, I wouldn't say term, but rule, is that when we're looking at angles of inclination, remember one word. It's called gradient, right? We know what it is. We've worked with it before. Just keep that in mind when we're doing the examples. So we have 3 examples here, but let's start with the first one. So if you look at this diagram, how am I going to find theta? You can use 2 ways. One, you can use what we know about theorem of Pythagoras, and we can do x squared plus y squared equals to r squared, or z squared, since it's not a circle, and we can find this angle, or we can find this angle. But if we find this angle, then we can say that opposite angles are equal. That's what we learned, right? But the method that we want to use is using trigonomic functions. Now with trigonomic functions you have 3, right, that we will usually use. We use sine, cos, and tan. Now for sine we have an acronym. Okay, it is SO, CA, TOA, right? And that means that sine is equal to opposite over hypotenuse, cos is equal to adjacent over hypotenuse, and tan is equal to opposite over adjacent, right, on a given triangle. So which one of the trigonomic functions would we use in this example? Now we could use sine, but we'd always need to calculate the hypotenuse. But that's the same for cos, right? So both of them require us calculating an hypotenuse. So I can't use that. I wouldn't want to use the 2, because if I have examples where I have coordinates or examples where I have only one point, it's going to make it really difficult. So we don't use sine or cos, not just because they can't be used or because they don't adapt here, but because they just don't make sense to use it. And you cannot use it when you're working with certain examples. So the only trigonomic function that we use when we work angles of inclination is tan, right? So we look at tan theta, tan alpha, tan beta, whatever the angle is. And for that, we need to remember one important thing. When we work with tan theta is actually equal to the gradient of a line, right? So tan theta is equal to gradient. Or we can say that tan theta is equal to y2 minus y1 all over x2 minus x1, which is just your gradient, right? So let's try. Let's say tan theta is equal to the gradient, because we're using theta here. The gradient is y2 minus y1, x2 minus x1. This is going to be equal to, if this is 3, y is 0. So my coordinates for this point is 3 and 0. My coordinates for this point is 0 and minus 5, right? Because it's cutting the axis. So I get minus 5 minus 0 all over 0 minus 3. This is equal to minus 5 over minus 3, which is just equal to 5 over 3. So tan of 5 over 3. You go inverse tan or arc tan. Can you see that? Of 5 over 3, and that will give me my angle, right? If it does not tell you how many decimal points to round off to, we said that we will round off to 2 decimal points as a rule. So theta then is equal to 59.05 4 degrees. Right? Let's do the next one. So we already know all of the terminology. We already understand what we're doing. So let's go to the next one. To find alpha, we say tan alpha is equal to y2 minus y1 over x2 minus x1. That's going to be equal to, let's choose any one, 5 minus minus 2 over 1 minus 4. This is equal to 5 plus 2, which is 7, over 1 plus 4, which is 5. Right? That's going to be arc alpha of tan. So arc tan of 7 over 5. Therefore, alpha is equal to 54.46. Right? Why 46? Because we are rounding off to 2 decimal places. Then we look at the third one. Now the third one is different. Why is it different? If I find the angle, or if I find the gradient will give me this reference angle. Right? That's what it's called. It's going to give me a reference angle. So let's first find the angle and then we'll explain a bit more. Tan beta equal to y2 minus y1 over x2 minus x1. Remember here that the point is 0 and 2, and here it is 3 and 0. So basically they're intercepts. Do you remember what intercepts are? So those are our 2 intercepts. So we're going to have 0 minus 2 over 3 minus 0. This is going to be minus 2 over 3. Now, important, when we work with this, put it in the calculator as is. So I'll have tan inverse of minus 2 over 3. That will give me a negative angle. Can you see that? The angle is not negative, right? Because you're not going to get negative degrees. So ignore the sign. So in this step, actually, you can ignore what the positive and negative is. This is the gradient, but you're not asked for the gradient, you need the angle. So remember that it's not beta that we found. So in fact, we shouldn't say tan beta. We should say tan of your reference angle. So you can say, therefore, your reference angle is equal to 33.69 degrees. Right? So what did I get? I got this angle inside. What do we know about angles on a straight line? Angles on a straight line equal to 180 degrees. Therefore, I can say that beta is equal to 180 degrees minus 33.69 degrees. Right? Put it in your calculator. That's the angle you get correct. I'm looking at 146.31 degrees. That's going to give me this beta angle. It seems like a lot, but if you think about it, 90 degrees is actually this point here, right? Because it should be perpendicular. So that should be your answer. Remember, if you got to this step, right, and you got this angle, 33.69, you can see that it's impossible for beta to be that value. Why? It's already passing 90 degrees. How can it be even less than that? So that's just a way for you to check your answer and know that, hey, maybe it's incorrect or something's not working out here. Remember that when you're finding the angle, it's going to give you the inner angle like it did here, and that's your reference angle when you're looking at the outer angle. When you're looking at the outer angle, use your reference angle, line on any angles on a straight line, all the angles equal to 180. it might not even be one angle. So say for example, if you had a graph, let's just draw it anywhere. So if I had a Cartesian plane like this, right? This 90 degrees could be broken up into all different angles. But all of them, all of the angles on that straight line is what is equal to 180 degrees. Right? So in this case, it's 2 angles. In other instances, it might be 3 or 4 or more. So this is how we do angles of inclination. Remember, we use tan theta and only tan theta. And tan theta is also equal to the gradient of the line. And we can find reference angles to find our actual angle that we're looking for. So get out your workbook on angle of inclination, and I will see you in the next lesson.